And now I'm going to work the first half of practice proficiency number 3. And for this first half, this is going to be all review. That is stuff from the very beginning of the school year. So I'm going to go through the first half of this, numbers 1 through 5, fairly quickly. For number 1, it's asking which equation represents the relationship between x and y in the table below. So I am not going to choose A, because A says y equals 1/3. Notice there's no mention of the x even in there, which makes it pretty hard to show the relationship between x and y if there isn't even an x in option A. Also, y equals 1/3 means that every single value of y would be 1/3. And as you can see, that is certainly not the case. I'm not going to pick option B for the same reason, because it says that y should always be equal to 3. Well, none of these are 3, and the fact that this just says y equals 3 means that the y value should always be 3. So A and B are not options. I'm not going to pick option D, because D says that if I take x and I add 3 to it, that'll give me my y value. So let's try that out. 4 plus 3 is not 12. So D is not the answer. Last but not least, let's try out option C. Remember, when that 3 is just sitting next to the x, that means multiply. So this is saying that to get y, I need to do 3 times x. Well, 4 times 3 is 12, 5 times 3 is 15, 7 times 3 is 21, and 8 times 3 is in fact 24. So the relationship for the two of these is in fact C. For number 2, I need to know what the solution to this equation is. And I always like to kind of rewrite the equations over here where I've got a little bit more room. And you'll notice that the 3 is sitting next to those parentheses right here on the left-hand side. Whenever you've got anything sitting next to something else in algebra land, it most of the time means multiplication. So this 3 sitting outside of the parentheses means I need to take this negative 3 and multiply it by everything in those parentheses. Remember, that's called using the distributive property. I'm going to take the negative 3 and distribute it inside of the parentheses. So negative 3 times 7x is a negative 21x, because it's a negative times a positive. Negative 3 times 15 is a negative 45. Remember, I can just do minus 45 or plus a negative 45, either one. Now I'm just going to bring down my 9 plus 6x, because I can't add together 9 plus 6x. So now I need to look at either side of my equal sign. So over here I've got an x, over here I've got an x. Remember, when we're trying to find a solution to an equation, we want to end up with a variable on one side and then a number on the other side. That means I need to get rid of one of these x's. It doesn't matter which one I get rid of. I personally would get rid of this negative, because that's where I used to make a lot of mistakes. So to get rid of this minus 21x, I'm going to add 21x, so that is going to cancel. Because it's an equation and it has to stay balanced, I added a 21x over here. So I'm going to add a 21x over to this side. 6x plus 21x is 27x. Remember, I'm not going to add this 21x to that 9, because I can't add 9 to x's, because I can't combine numbers and variables. I still need to bring down this negative 45 that I have over here. So I canceled out that 21 with a plus 21. So now that's gone. I have a negative 45 still left over. Lots of people forget to carry down that negative 45. I added 21 over here. So I'm going to add 21 over to this side. So now I've got 9 plus 27x. I still need to get that x all by itself. So I need to get rid of that 9 with a minus 9. That is going to cancel and leave me with 27x. Now, what a whole bunch of people did in class, I've noticed, is that they got rid of this negative 45, which wouldn't necessarily be wrong as long as you finished out the problem correctly. But think about it. If we're trying to get something so that we end up with an x by itself and then a number on the other side, getting rid of this 45 over here on this side of the equal sign doesn't help us to get this x by itself. What's going to help us get the x by itself is getting rid of the 9. So that's what I chose to do. So because I subtracted 9 over here, I have to subtract 9 over here. Negative 45 minus 9 is a negative 54. So now I'm left with 27x Remember, when anything is sitting next to the x, that means multiplication. To cancel out that multiplication, I'm going to divide by 27, which will cancel and leave me with an x. I divided this side by 27, so I'm going to divide that side by 27. Negative 54 divided by 27 is a negative 2. So my answer should have been A, negative 2. For number 3, I am going to, first of all, recall what it means for something to have no solution. Remember, no solution, and this is a really basic example, means you're going to end up with something like this, like x plus 1 on one side of the equation, x plus 2 on the other side of the equation. X plus 1 can't possibly be the same thing as x plus 2, because this side is always going to be bigger, right? Because you're adding 2 over here, but you're only adding 1 over here. So I'm going to look for something where the sides are mismatched. First of all, this x squared, this is not something mismatched because I can actually solve this by dividing both sides by x to get rid of this extra x. So this is going to leave me with x equals 2. That is something that we're going to deal with a little bit more next year in Algebra 1. Okay, so it's not D. Now I'm going to look at, it's tempting to go right here to B and say that that's it. X minus 5 equals negative 5 plus x. Because some people might be like, oh, well, those sides don't match, so that's the one that's no solution. Well, no, because x minus 5 is really the same thing as negative 5 plus x. They're just flip-flopped. Because I can switch this around. So instead of doing negative 5 plus x, I just do x minus 5, and it'll work. So that is not the correct answer either. Now I'm going to use my distributive property, just like I did in the last problem, to get rid of the parentheses in option A and see whether or not it ends up being misbalanced. So 2 times x is 2x, 2 times 6 is 12, so I have 2x plus 12. And then I've got 2x plus 12 on this side. Well, this isn't a mismatch. This is an exact match. So this one wouldn't be no solution. Remember from before, this would be infinite solutions. Because since the two sides are exactly the same, any number on the planet will work for x. So option A is not an option either. So A, B, and D are all 3 out. That means it must be C, but let's double check and see why. Again, I'm going to use my distributive property. So 3 times x is 3x. 3 times 6 is 18. Now I have a mismatch because on this side I have 3x plus 18, whereas on this side I have 3x plus 6. So both sides don't match. Therefore, this is the one that is going to be no solution. So the option I should have picked is C. In our review section, number 4, we're going to keep going on here. It says, which table contains values for a linear function? Remember, linear means if you were to graph them, they form a straight line. So one thing I could do is I'm just going to graph these guys and see which one turns into a straight line. So right here, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If I'm going up, oh, I didn't space that out very well. Sorry, guys. Remember, you guys can use graph paper at home. Your proficiency does have graph paper on it. 1, 2, 3, 4, 5, 6, 7, and 8. Still wasn't a great job. That's okay. So for this first set of ordered pairs, I'd go over 1 and up 2. For this next one, I would go over 2 and up 4. Next one, I'd go over 3 and up 6, over 4 and up 8. Oh, option A, already I can see that if I graph them, because remember the X number tells you whether you're going right or left, the second number, Y, tells you whether you're going up or down. So I went over to the right one and then up 2 for my first one, so over 1 and up 2. Here I went over 2 and up 4. Here I went over 3 and up 6. Here I went over 4 and up 8. So it does in fact form a straight line. So it's going to be table A. What if I don't want to graph it? Remember, there is a shortcut. And what you can do is look at your rate of change. So let's look and see how my y value is going up. 2 over 4, that's going up by 2. This is going up by 1. So this rate of change is 2 over 1, because remember, it's your change in y over your change in x. This one is going up by 2 over 1. So remember, this is a rate of change of 2 over 1. And this one is 2 over 1. So all the way down, this one has a rate of change of 2 over 1, then 2 over 1, and 2 over 1. Remember, that is called a constant rate of change. Remember, rate of change is however much your, don't know why I added a y to that. Remember, your rate of change is however much your y values are going up over how much your x values are going up. So 2 over 1, 2 over 1, 2 over 1, well, that's a constant rate of change. So for both of those reasons, A should have been my answer. So when you're asked to find out whether or not something is linear, you can either graph it and just see if it forms a straight line, or look at your rate of change. Your y values are going up by 2 over 1 for every single set, so that means it has a constant rate of change, which means it'll be linear. Last but not least, number 5, it says the graph shows the distance she traveled over time. According to this graph, which statement describes Amy's trip between 1 and 2 hours? So I'm going to look right here at hour 1 and hour 2 and at where it falls in between. So between 1 and 2, she went from 60 miles up to 90 miles. So in 1 hour, she traveled 30 miles. So that means that D, she was traveling at a rate of 30 miles per hour, should have been our answer. Last one in the review section is number 6. It says, which best describes the solution for the system of linear equations graphed below? When you've got, so a system of equations is when you have more than one line. And an example of a solution for the two, is just when the two graphs cross, like where on the graph they would cross. So let's say I've got a line that goes here and one that goes right here. Well, the solution for those two equations would be right here where they cross, which is over to the left 5 and then up 1. So that'd be negative 5, 1. So wherever they cross, whatever point they have in common, that is the solution when you've got two equations at once. Well, looking at these two, they're parallel to each other. They're never going to cross anywhere. So that means that they have no solution. It's that way whenever you have two parallel lines, there's always going to be no solution to that system of equations. So remember, if they cross somewhere, wherever they cross, so this would be negative 5 and then down 2, so negative 5, negative 2. That would be a solution to these two equations. But whenever you've got two lines like this that never cross, they have no solution. That means there's no place where they're going to cross. They have no points in common that work for both of them.